Hi guys, welcome to Learning Hub. Today we will learn about the topic tree, which is the most important topic from the data structure. We will go through some basic terminologies related to the topic tree. So let's start. A tree. A tree in data structures is a hierarchical data structure consisting of nodes, where the topmost node is called a root node. Means what? A tree is nothing but a hierarchical data structure where this topmost node is called as a root node, and each node may have a child nodes connected by edges. Means suppose now this is a node C which has its child node D and E, and these two are connected with each other with the help of the edge, with no cycles and only one path between any two nodes. Means there is only one single path between any two nodes. And the most important property of the tree is that it does not form any kind of cyclic structure. For example, in the first graph we can see that here a cyclic structure is formed. So this is not called as a tree. The second example is known as tree. Next. Now there are some basic terminologies of tree such as rooted tree. Now what is rooted tree? The topmost node in a tree which serves as a starting point of the hierarchy. Means in any kind of tree structure, whichever is the topmost node, that is called as a root node. In this hierarchy here, A is the root node. Now next is parent node. A vertex other than root node is a parent node if it has one or more children. Means if any node has one or more children, that is nothing but the parent node. The node which has children, that node is parent node. So here, which node has children? Here A has two children, B and C. B has two children, D and E. So here parent nodes are A and B. Next is child node. A child tree data structure is a successor node that is directly connected to its parent node, one level below it in the hierarchy. Means child tree data structure is nothing but a successor node. Successor means what? After the parent node. Child node comes through the parent node, one level below it in the hierarchy. So here B and C are the childs of A. D and E are the childs of B. So here what are the child nodes? B, C, D and E. Next is siblings. So what is exactly the siblings? Children with the same parent vertex. Means what? Now here A is the parent of B and C. Means B and C belongs through a single parent. Means अगर basic example देना हो तो हम और हमारा सगा भाई. So we both belongs to a single parent. Okay. So we both are siblings. Now comparing this example with this, we will get that children with the same parent vertex is called as siblings. Means what? B and C came through the same parent, that is A. So B and C are siblings to each other. Here also D and E are siblings to each other. Why? Because they belongs to the same parent B. Okay. Next. Now level. The length of the unique path from the root to the vertex. Means level is nothing but, now see here, for example, P is at which level? It is at level 0. Q and R, this is level 1. Now A, B, C, D, this level is level 2. Means like that level goes on increasing from top to bottom. So here the level is 0, here it will become 1, 2, here 3, here 4. Nothing else. Height. The maximum level of all the vertices. Now the first and most important point for the height is that the height of the tree is counted from the bottom to top. Controversy to the level. Level is counted from the top to bottom, but height is counted by bottom to top. How? Let's see. So from here till P, what is the height of the tree? From H to M it is 0, M to C or M to D it's 1, D to R it's 2, R to P it's 3. So the height of the tree is 3. Okay. So leaf nodes. The vertex with no children is known as leaf nodes. So here in this example, here B does not have any kind of children. C, E, F, G, then here H, I. It doesn't have any kind of children. So these vertices are known as leaf nodes. The vertex with no children is known as leaf nodes. Then controversy to the leaf node is internal vertices. What is internal vertices? The vertices that have children, means here the vertex P has two children. Here Q also has children. Here C has children, M has children, L also have these three children. So the internal vertices is nothing but the vertices that have children is known as internal vertices. There is nothing rocket science in this. So here P, Q, R, A, L, M, R, as I said, are the internal vertices. Next is ancestors. So what is ancestors in simple language? Ancestor means our parents or our grandparents or our great grandparents. Means an ancestor of a node is any other node on the path from the node to the root. Means here, who is the ancestor of A? The ancestors of A are Q and P, because A have been derived from the terms or from the vertex P and Q. Here, who is the ancestor of C? R and P. Okay. Likewise, opposite to the ancestors is descendant. It is a node that is a child of an ancestor. In easy language, descendant means our children's or our grandchildren's. Here, the descendants of A is L. Here, the descendant of P is R, C, etc. Okay. Here, the descendant of C is M, H, etc. Okay. Subtree. A subtree is a portion of a tree consisting of a node and all its descendants, forming a smaller tree within the larger tree. Means a subtree is nothing but here, you see this highlighted part with the blue dotted line. This is a larger tree, but in the larger tree, when it forms a smaller tree which have similar parent nodes as well as child nodes, this portion is nothing but the subtree. The next last part is emery tree. This concept has been brought throughout by the binary tree. Binary tree is nothing but having two nodes equally, left and right nodes. So the name for that is binary. Bi means two. So here a tree or a rooted tree in which each node can have at most m children. It is represented as m-array tree. M means nothing but it is a count of at most children's. Okay. So here in this example we can see that vertex 1 has 3 children's. Okay. Vertex 2 has 3 children's. 4 also has 3 children's and 3 has 1 children. So what is the at most count of children is 3. So the value of m over here is 3. So if the child may contains, if some vertex may contains 4 child, then the value of m will become 4. What is the at most value? That is the value of the m. So it is represented as m-array tree. So here in this example, this tree is known as 3-array tree. Okay. Yes, thank you for watching.